And hello, welcome YouTube. Welcome back to our little tutorial. Okay, so last video we just made a simple cylinder of radius 7 millimeters, and we're trying to make a heat exchanger. Remember, and basically we are trying to have the shell side or the shell thickness. I mean, the copper interface between the shell and tube. That pipe is supposed to be 2 millimeter thick, so overall this radius should be 9 millimeter. So I'm going to make another, and yeah, we are trying to make a heat exchanger in salome. Use that to do our meshing, and then after that use OpenFoam to create the multi-region effect. So, okay, again, just going to do the freeCAD part. I'm going to skip all the introduction. I assume you know a little bit already. So I'm just going to make a circle here. I'm going to make this circle a 9 millimeter circle. 9 millimeter circle. Okay, now it's okay. So once it's done, I'll just pad this thing. Okay, I'll just pad this thing, right? I'll pad this and I'll make it 200 millimeter. And of course, it's going the wrong way. It's padding the wrong way, so I'll need to just press the reverse. Alright, so that is pad number 2. Okay, pad number 3. Okay, okay, pad number 3. Pad number 3, yeah, I always get confused because there's so many what do you call that? So many ways of navigating, like salome way, the freeCAD way, and the paraview way. Okay, so this I'm making yet another sketch using another datum plane. I cannot have all 3 circles on the same sketch. It will give me an error. I cannot pad it up properly. So I have to make one datum plane and one sketch for each datum plane in order to make this work. So let's make another sketch. Again, the last sketch will be here. And again, I'll make this 14 millimeter in radius. So that should be 14. Okay, so that will be the last layer. Alright, I hope I got it right. But anyway, the most important thing is the padding. To get that right, not too much. Yes, looks like this time. Let's see, it's also padding the wrong way, so I need to do a reverse. Now do a 200 millimeter padding. Click OK, and we see that we have our 3-layer pipe now. Not too bad. Alright, so now we have all these 3. Then we need to start making our inlet and outlet for the shell side. So that again is pretty simple, straightforward. Okay, make a datum plane. Okay, I will turn this datum plane around. I'll pitch it around 90 degrees. Okay, then I'll offset in the X direction. So you can see the coordinate system at the bottom right hand side. Okay, at the bottom right hand side. So I want to shift this datum plane. Okay, I want to shift this datum plane that you're seeing now a little bit out. Excuse me, a little bit out. Okay, a little bit out. So let's put this about 10 millimeter out in the X direction, so that your datum plane is here. Once this datum plane is here, I'll be able to start doing, you know, I'll be able to start doing this circle drawing. Alright, so that's how I do my datum plane. I'll be able to do my inlet and outlet. Remember, those are spaced 20 millimeters from the end and 5 millimeter in radius. So I'm going to start my sketch. Okay, as you can see, the sketch is conveniently, the end is conveniently where the end of the tube is, or the end of the whole heat exchanger is. Alright, because I initially started the datum plane from the end of the heat exchanger, so that actually makes it more convenient. Okay, so when I started the datum plane, it was with this side as reference. So even if you pitch it around, you turn it around, it will still be that point. Okay, it will still be that point, and it's convenient for us to do so. So let's put an inlet and an outlet. Alright, so remember the dimensions. Okay, the circle should be somewhere here. I don't know where it is because this pad is blocking. Okay, so this circle can move up and down, but I want to constrain this, so I'm going to click these 2 points and I'm going to give it 20 millimeter. Okay, let's try that again. 1, 2. I'll click these 2 points and I'll give it 20 millimeter. Alright, and this circle radius should be 5 millimeter. Okay, again, I assume you're familiar with this, alright? So if not, please watch my other FreeCAD videos. I'm not going to go through the same concepts again. Okay, so and the FreeCAD videos will be in the OpenFoam Intermediate series, just like what I showed you in the last video. Okay. Anyway, so here and here, I will have 160, right? 160 millimeter, because the whole thing is actually 200 millimeter. So 200, 20 from each end. Okay, 20 from this end. Oh dear, I think I got it wrong. Let's see. Oh right, great. My holes are gone the wrong way. So let's delete this. I will need to do something. I'll delete this constraint and I'll move this. I'll move this here. Okay, and now I will make this 20 millimeter. Okay, now it's right. So let's turn on the pad. Alright, yeah, so this is what it should look like. And if the whole thing is 200 millimeter, if this whole heat exchanger is 200 millimeters, having the other side 20 millimeters from the end, okay, that will mean that this is 20 millimeter, this is 160, so both of them add together, you have 180 millimeter, so that the other hole will be bored, will be sort of 20 millimeters from the end. So okay, once I do that, I can close this and let's make this also 5 millimeter. So let's make this radius 5 millimeter. Okay, 5 millimeter. Okay, and now the sketch is fully constrained. As you can see, all of them are in light green. And I can close. Once I do that, I can turn my pad back on. Alright, and of course I can start to pad. Okay, and you can see the default 10 millimeter is just enough. I didn't measure how much that thing should be, how much padding I should give it, but it's very short. As you can see, it's like, yes, perhaps it's about 10 millimeters. So this is about the right dimensions that I want, and that was how I make this shape in FreeCAD. Now this is the easy part. The more challenging part, it's going to Salome. So I will have to export this whole file as a step file. So I have to export this, export as a step file. So video tutorial .step. So there I will save it here. Okay, and this one I can close it. So I'm pretty much done with the FreeCAD bit. Okay, and for Salome, I can just do a new thing. I don't want to save before closing. I can make a new study in Salome. I will make a new one and I'll save it in here. I won't save all the one pipe heat exchanger. I'll just do vid tutorial.htf. This is a Salome study file. I'll save this and I'll go to the geometry part and I'll just import the step file. Same as what you should know already when you're doing even the single region case like pimple foam, where you have only one region you have to deal with. Same idea. So I'm just going to do this video tutorial thing, and Salome gives you the option to, at least Salome 9.5 gives you the option to take account the units of millimeter, which I don't want. I want to do this step in OpenFoam, the conversion from meter to millimeter. Okay, I want to do that. So alright, so I have this new pad in here. Unfortunately, I don't have the complex shape that I want, so I cannot really do the meshing part just yet. If I do the meshing of this, then all I will get is I will get a very funny shape, and I don't have the multiple regions that I need. Okay, I will just have this this basic circle, all of that will be there with the different patches, but nothing else will be there. There'll be no multi-region case. So the trick is we need to start making the complex shape and the complex regions from the simple shape we have here. We either do it here or we do it in freeCAD, but if we do it here in Salome, there's somewhat more control. Alright, there's somewhat more control for you. So I already taught you, or rather showed you, how to do some of the basic navigation over here in Salome, so I assume you know all these before starting. If not, go and watch the other videos. Alright, so yes, in my intermediate series, everything is there. So now how do we actually start taking apart this this complex shape? Alright, I mean, at least all my borders are drawn there, the inner tubing, the copper part, and the outer shell, all of these are there. Okay, so I will need to make a series of shapes. So I'll need to make the inner tube, the center piece, the center part, and then the center copper part, and the outer tube. Okay, so this is a shell and tube, the most basic shell and tube you can make. Alright, so what do we then do? Okay, first thing first, we may need to separate all of these out into various faces. Okay, there's a relatively easy way to do that. It's called explode. And after that, what you can do is to start making volumes from each of these faces. So let me show you what I mean by that. Okay, so the way I did it, it may not be the most efficient way, but it's easy to understand and get started. Okay, first thing I do is to explode, is to make all these things into different shapes. So under new entity, there's this thing called explode. Okay, and then it will tell you it can explode it into some subshapes. So you are given a main object here, which is the pad 003, which is the whole heat exchanger. These are default names, I did not give it any other name. Okay, so you have the subshape type. It is you can select shell, you can select face, you can select wire, edge, or vertex. They don't give you the option to split it into multiple volumes, which is of course unfortunate, because if they give you the option to explode it into multiple volumes, your life will be very easy. Okay, unfortunately that's not the case, so we'll go for the next best thing. We'll just explode it into all the various shapes. So once I do that, I just click apply, and you can see under here I will have various shapes. So for example, this is phase 1. Phase 1, what is this? This is the outermost cylinder bit, and you can see there are no cylinders like underneath. You can see that there are no inner cylinders between, like, let's say the tube side. The tube side here, all you see, there are two faces of the inner tube, but there's no surface describing the interface between this inner tube and the copper. Likewise, there's no interface between the outer shell and the copper. All of that you'll have to include it yourself. You'll have to start making all of this in Salome. Okay, so that's the phase 1. This phase 2 is the one side of the copper. So conveniently, we can do the naming here. I'll call this curved shell surface, because that's what it is. Curved shell surface is here. Okay, so I'll take off the curved shell surface. This one is the copper. I'll call this copper N1, because it doesn't really matter what copper N that is. So that's copper N1. So where's this thing? So that is the tube. So I call this tube N1. Okay, not to confuse the name, of course. The other thing we can do is to try and make this thing a little bit wider. Yeah. Give it a little bit more space so you can see the names, because you can adjust it as so. Okay. Once we do that, I can take this tool off, and let's see what phase 4 is. Phase 4 is actually the shell. So I call this shell N1. This is just for convenience that we can sort of name our stuff later. Okay, so that's shell N1. This one will be copper N2. I'll call this copper N2. Okay, so I'll keep continuing the process till every phase is named. This is tube N2. Okay, tube N2. And phase 7 will be shell N2. Okay, shell N2. Okay, so phase 8, 9, 10, 11. Let's see what this is. Phase 8. So this will be, let's call this the inlet then. Phase 8 is the inlet curved shell, inlet shell curved, because this is the inlet to the shell. You have this curved pipe, the curved surface. I'll call this inlet shell curved. Phase 9 will be outlet shell curved. Okay, outlet shell curved. Okay, this is just for neatness sake, and this will be then, I'll call this the shell, inlet shell. And of course the last one will then be outlet shell. Okay, so this is how I name all of these surfaces, so that life is easier. I don't have to guess what each of these surfaces are, because I already named them. Alright, now once I have these, what do I need to do? I need to start making shapes. So the easiest way to name shapes is the easiest shape to make is of course the inner curved surface, and I want to start making the tube part. So I'm going to hide everything except for the tubes. So I'm going to hide everything. So let's look for the tube. So there's a tube. The only two surfaces that are relevant to the tube are the tube N1 and the tube N2. Right, nothing else. So from this, I need to actually make a cylindrical shape. So how do I do that? So I need to make this cylindrical surface. Okay, and the thing I need to do is to go to create a new group, and I need to make a new face. Right, so what is the shape? The shape will be this pad 003, and that will be the proper shape. Okay, or rather, no, I don't do that yet. I don't make a face, I'll make an edge. Okay, so this edge will be called tube N2. I will call this tube N2 edge. Okay, let's see whether I can. Oh, right, I need to select this and add tube N2 edge. Okay, so tube N2 edge has been added over here. Alright, and I will need the other side as well, tube N1 edge. And from these two edges, I can start making a surface. So let's go to the other end, and I will select this to be the main shape, tube N1 to be the main shape, and I will just select this piece and I'll add it here, and I will apply. So let's see whether tube N1 has the edge here. So these two are already there. So what I can do, hopefully can do, if I remember how to do this right, is now I need to make a new entity. I need to make a generation, and I go under generation under new entity, and I say I need to do something called filling. So what filling does is to take two edges, and after that it will what do you call that? It will make a surface from these two edges. So this is called filling 1. Actually, this is actually tube to shell. Alright, the input contours are just these two, tube 1 NH and tube 2 NH. So this is tube to shell. Oh, maybe I call it tube to copper. Alright, this is called tube to copper. And I'll just do apply and close, and you can see that the main cylindrical shape has been created. Now that you have this main cylindrical shape, what you need to do is to start making the cylinder, the 3D shape, because you're not finished yet. So I need to select tube to copper, tube N2, and tube N1. What I need to do, okay, oh, my time is up, but anyway, what I need to do is actually to build a solid. So under new entity, go to build and go to solid. Don't worry if you miss it, because the process is pretty repetitive. All right. So under solid construction, I will need to make a solid from a set of connected faces and shells. So by default, you will be selecting this blue thingy here, but I want you to, okay, the way I did it is to do it from a set of connected face and shells. You'll be able to see this thing here. All right. So select this and get your objects. One, tube to copper, tube N2, and tube N1. And you just click apply. Okay, and you have to do intersect and sew shapes. So check that box and make sure you apply it. And we'll call this thing tube. Okay, so this is how we make a solid from the inner solid from this set of surfaces. I know it's a bit of a workaround, a little bit of work to do, but it's good to get used to it so that you know how to do multi-region foam. So we're going to repeat this, actually, you're going to repeat these steps for the other two regions in the next video. So thanks for watching, I'll see you guys again, bye bye.